Hello, welcome. Let's try to solve a Leetcode problem. So for this problem, it is 995, minimum number of k consecutive bit flips. So the idea is that we are giving an array nums, and for this nums, let me just use the first example. So it's going to be like 0, 1, and 0, and we have a window size, it is k. So for the window size of k, it means for the length of the subarray, if it is equal to k, we can flip the 0 to 1 or 1 to 0. So if k equal to 1, it means for this 0, we're going to flip it to 1. And for this 0, we're going to flip it to 1. So there are two operations. So we're going to return a 2. Now let's check a more complicated example. Maybe this one. We have two ones, we don't need to flip. But for this 0, definitely we need a flip. Yeah, but the length should be 2, but here this length is only 1, it means it's not possible, so we're going to return a false, -1. And for this one, this problem gonna be, this example gonna be much interesting. So first of all, we're gonna flip those 3 zeros to 1, and this one is okay. Now for this 0, we're gonna flip it, but we're gonna flip the window side, it's gonna be 3, so it's gonna be 1, 0, 0, and 0. So the last step, we're gonna flip those 3 zeros, it's gonna be 1, 1, 1. So how many steps? So it's gonna be 3 steps, so we're gonna return a 3. So the brute force idea is just like that. So from the left to the right, and we're gonna check the window size, so it is okay. And if it is equal to 0, basically we're gonna flip these areas, and then we're gonna check the next one. If this is 0, we're gonna flip it, and then if this is 0, we're gonna flip it. So the time complexity gonna be n times k. So n is the length of the array, and k is also the length of the array, so it becomes n squared. Definitely we cannot pass because it is 10 to the power of 10. We cannot pass it. Yeah. Now, we're going to use this kind of idea to solve the problem. Basically, we're going to use this idea is also like a greedy idea. So, for example, if we have 3 zeros and this is 1, how can we flip it? Of course, we're going to flip from the left to the right. If we find a 0, we're going to flip it. But what if we flip through the window, in the middle, for example, this 0? So we're going to flip it, it becomes 1, 1, 0. Yeah. Now it becomes not possible. Yeah, because it is not the greedy way. So the greedy way is always from the left to the right. If we find a 0, we're going to flip like a group, and the size is going to be k. Yeah. Now we're going to continue to use this idea to solve the problem. So according to the description, the idea is that we are having this kind of array, and inside of the array there are going to be numbers 0 and 1. We don't know, but definitely there will be the numbers 0 and 1 inside of the array. Now we want to flip it according to the greedy way. So from the left to the right, if we find a 0, definitely we're gonna flip it. So for example, if the window size is k is up to here, so this is the window size k. So if we want to flip it, this is 0, definitely we want to have a flip. After flip, this 0 definitely have a 1. But what about other numbers? We just need to record other numbers, but we don't need to go through the array, go through the window size like the window size of k. We don't need to check one by one. We just need to have a record at the end of the prison. For example, this is a 1, and this is a k, and the next prison is going to be k plus 1. So at the next prison, we're going to have a record of it. So here, we have a flip, it's going to plus 1, but after that, at k plus 1 prison, we're going to use a -1. So as you can see, this is going to be like a prefix sum. We don't need to check one by one, but we just need to prepare a start prison and add prison, and then we're going to use the prefix sum to solve the problem. Now, in the middle, in the between, for example, this is 0. This is a 0. For example, just, yeah, maybe I'm going to set this to 0 as well. Maybe this is 0, yeah, I'm going to check in this 0. For this 0, I want to check how many flips do I have. And I'm going to use a structure, I'm going to use an array, or I'm going to use a prefix variable to record how many flips do I have. So I'm going to maybe I'm going to use a flip just to record how many flips do I have. Maybe at here I have a flip equal to 1. So this means I don't need to flip this one at this position, because this is 0, and 0 plus 1, it is already a 1. So if it is 1, it means I don't need to flip. But what if this number is 1? But I have a flip of 1. It means this number has already become 0. So this means I need a flip to make it to 1. Yeah. So if we understand the idea like that, basically we're gonna solve it. Now let's just review what is the difference array idea. So the difference array idea is used to solve the problem. So if we have a start prison and add prison, so this is a start prison and this is a add prison. Normally at the start prison we're gonna plus equal to a value, maybe 1. At the add prison we're gonna minus a value. So here we're gonna plus a value, here we're gonna minus a value. So in this way we keep a fixed window size k, but in the windows, because we keep this kind of a difference array structure, so this means at each of the prison definitely we know how many flips. So for example, from here, in this range, definitely we know there's a flip. So while goes here, definitely we know maybe at this prison there are 2 flips, because here is in the range, here also in the range. Maybe it comes to here, there's only 1 flip, and here only 1 flip. But while it goes to here, the flip becomes 0. So this is the difference array idea, and this is why it can solve this kind of problem. Of course, there's another way to solve it using the sliding window. We have a window size of k, but I think I will talk about that later. So now we're gonna focus on the difference array idea to solve the problem. So I'm gonna prepare a variable n. It's gonna be length of the nums. Now I'm gonna prepare the difference array. It's gonna be 0 times n plus 1. Because the end prison is also included. For example, we can flip from the first prison to the last prison. Definitely every prison gonna be included. Yeah. Normally for the array, it's gonna be 0 times n. It's gonna include all the prisons. But for the difference array, if the end prison is included, basically we need an actual prison. So I need to plus 1, because definitely it is something like at prison S it's gonna be plus equal to 1. At prison E it's gonna be minus equal to 1. Yeah. At prison E plus 1 gonna be minus equal to 1. This is why we're gonna use n plus 1. Now I want to prepare the result and flip. I'm gonna set it to be 0 and 0. This flip and just use it to calculate how many flips do I have. So the idea is that this is just a range, this is another range, the window size is k. At any prison, I want to have a record of how many flips do I have. So this is the meaning of the flip. Yeah. So maybe at some prison, maybe this is a 0. Maybe I want to flip it, so this window size is going to have a flip. Maybe this window size is going to have another flip. So this means in this prison, the flip is going to be equal to 3. So this is the meaning of the flip. So it is a prefix sum array, but here it is a prefix variable. So this flip is actually a prefix sum variable. So it means at each position I'm gonna have a record. For example, at here it's gonna be 3, at this position it's gonna be 1, at this position it's gonna be 2, because at here we can see, yeah, inside the window there are 2 flips. Now we want to check through the nums. So for I in range n, the first step is that we want to have a record of how many flips. Yeah, as it is a prefix sum, so this flip gonna plus equal to the difference array. So for each of the steps, I'm gonna plus equal to this difference array fi. As you can see, this is a prefix sum structure. We just need to check how many flips do I have up to now. But the flips should consider that together with the value, with the num inside of the nums. I mean with the value inside of the nums, because definitely there's a formula we need to check. So the formula is for this number nums I, we need to plus the flip. And if it is a modular 2 equal to 0, definitely we need to have a flip. So let's just try to use an example. Maybe we're going to use this example for this number. So this is 0 definitely. And at this prison, we have a 0 flip. So this means nums I 0 plus 0 it is 0. 0 modular 2 it is 0. This means at this prison definitely we need a flip, right? So 0 gonna be flipped to 1. And let's check the next prison. This is 1. Because it is a 1, so nums I becomes a 1. And this flip and this flip gonna become as we know that the window size is 0 according to the difference array. The flip definitely it is still 0. So 1 plus 0 it is 1. So because the result is 1, not 0, so we're gonna not check it. So this means while it is 1, we will not check it. While this is 0, definitely we're gonna check it. Yeah. Now we're gonna continue. But there's boundary case if it goes out of the range. So if the I plus the window size k more than n, so definitely this means it is not possible. This means I plus k equal to n plus 1, but the difference array, the length is n plus 1. It means for the index, if it is equal to n plus 1, definitely it goes out of the range. It means it is not possible, so we're gonna return a minus 1. This is for this example 2. So for this is 0, we want to flip it, but this I plus k already goes out of the window. It goes out. If it goes out of the window, so for example at this position, this I equal to 2, 2 plus 2 equal to 4, and this 4, 2 plus, let me check. So this I plus the window, I think this numbers I is 2 plus the window size, it is 4. It is 4. It is more than the length of the nums, more than 3, as we can see. It means it is not possible, so we're gonna return minus 1. Yeah, so we have to understand it like that. Yeah, but for the difference array, it means it can never be more than or equal to n plus 1. Yeah, because it should be the length of the array is n plus 1. Difference array is n plus 1. Yeah, basically this is the edge cases we have to check. If it is goes out of the range, we have to return a minus 1. So if everything is okay, so flip would plus equal to 1, and the result would plus equal to 1, and this flip at this position, and here we need to understand it, because at this position basically we are preparing something like the difference array. It means at position fi would plus equal to 1, but why not we just use fi plus equal to 1? Normally we can use, but for this kind of a structure, this kind of a difference array structure, if we use fi plus equal to 1, for the next checking, the flip plus fi, it is not this value, because this is the previous value. It's not the current value, and this is the current value. This is why we're going to use our accumulate variable, this flip plus equal to 1. Yeah, if you understand this area, so definitely I think you're gonna understand this kind of a solution. And basically this one, basically it means at position I plus equal to 1, the difference array idea. But currently we cannot use it, because this is the previous position and this is the current position. And now we are using a variable, and the variable can solve such kind of a problem, and we don't need to write so many lines of code. We just need to use this flip variable. It is called accumulated sum variable. Now, if everything's okay, we're gonna check the add position. So it's gonna be I plus k. It will be minus equal to 1, because at this position we're gonna set it to be minus 1, and at the start position we're gonna set it to be a plus 1. Yeah. Now, finally, we just need to return the result. So this is going to be the entire code, and the idea is just these areas. So for it, let me just clean these areas, and we can check together with the code. And for the formula, we need to understand it. For this kind of a formula, this is for each of the positions, the numbers can be a 0 or 1, because nums I can only become 0 or 1. So there are going to be some relationships with the flip. The flip can be the even number or odd number. So for example, if the flip is 0, so it means 0 plus 0, it means the result going to be 0. So modular 2, 0, it means the 0 should flip to 1. Yeah. So if this is 0 compared with another value, it is 1. So definitely 0 plus 1 going to be 1, and 1 modular 2 going to equal to 1. So we're going to not flip it. Yeah, because this is already becomes 1. The nums I already becomes 1. Definitely we don't want to flip it. And similarly for the 1, and you can check 1, just use the mathematics skills to check. So definitely we're going to need this kind of formula. Another one is that we need to understand the flip. Here is just the prefix some variable flip, and here definitely it means fi plus equal to 1. But we cannot use the fi, because this fi is the previous calculated value, and here we just need to plus equal to the current value. So we're gonna add this value directly into the prefix some variable. So it's gonna be the same idea. Yeah. So the result, there will be no difference. Yeah, but we cannot use fi. And here the result gonna plus equal to 1, and this gonna be the as precision. So normally it should be I plus k minus 1. Yeah, normally it's gonna be I plus k minus 1 for the end of the window, but we need to plus a 1, so it's gonna be I plus k minus equal to 1. Now let me just try to check and run it. As you can see, it works. Yeah. Now I want to submit it to check if it can pass. Yeah, as you can see, it passed, and it's pretty fast. And because the time complexity, currently it becomes ON. Because we didn't use 2 for loops, there's only 1 for loop and a check, and the time complexity becomes ON, 10 to the power of 5. That is why it's so fast. And I'm going to talk a little about the sliding window solution, because the idea gonna be the same. The sliding window idea is that instead of difference array, as difference array is just also like a sliding window here. But for the sliding window, we're gonna use a queue, and inside the queue, we're gonna have a record of the length of the queue. So the length of the queue, we're gonna put some numbers inside the queue. So it's gonna have some positions, for example, I and Z. So this I and Z is gonna be at I's position, we're gonna have a flip. At this position, we're gonna have a flip. So this means inside the window size, the length of the queue gonna become 2. So we have 2 flips. Now, but this I, it is the first position at the head of the queue, and from here, basically, with the head of the queue, we can check the window size. So if the window size is too big, so we're gonna pop out this index, and the queue gonna be reduced. Yeah. So according to the length of the queue, this is similar as the flip. Yeah. And with the flip, we're gonna plus the nums I plus this number nums I n. We're gonna check if it modular to similar formula. If it modular to equal to 0, definitely it means we can have a flip. Yeah, maybe I want to just try to code it, because if I just talk about it, nobody can understand it. Maybe I want to try to maybe use the sliding window solution to solve the problem. The sliding window is that we're gonna prepare the length of the nums, and it's gonna be equal to n, and I want to prepare a queue. It's gonna be the queue. Now I want to check the. Yeah, let me think about it. I want to loop through the nums. So let me use a variable r. So for r in range n. So we're going to have a check of the window size first. So if it goes out of the range, definitely it is not possible. So it's going to be the right position minus the left position. It is inside the queue. So this means we have to check the queue first. So if this queue exists and r minus q0 plus 1, so this is going to be the window size. So if the window size is more than k, it means it goes out of the range, because the window size should always be k. So if it goes out of the range, definitely we want to pop from the left side. So it's going to be q dot pop left. Yeah. Now the window size should be okay, and I want to check the result. Yeah. So yeah, now the window size should be should be okay. I want to check if there might be a possible result. So I want to use the length of the queue. The length of the queue, it means how many flips do we have. So if the length of the queue plus the current number is going to be nums r. If it is modulo 2 equal to 0, definitely it means there is a flip. So if there is a flip, I want to use a result plus equal to 1. So this means I also need to prepare a result. So this means I have a flip. Now I want to put some values inside the window, because inside the queue, definitely the position of the flip. So it's going to be q dot append with the position r. So this is going to be the position. Now I think I've finished the basic structure, and let me think about it. Do we need to do anything about it? So if it goes out of the range, so if it's equal to 0, I would to put it inside the queue, and the result would plus equal to 1. Yeah, I'm not sure, but let me just return the result to have a check. Yeah, maybe it is not okay. Yeah, for the second case, it is not okay. Let me have a check. So this is a result plus equal to 1, and this queue, I put it inside of the queue. Is there anything else? Yeah, I think if it modulo 2 equal to 0, I would to put it inside inside of the queue. Yeah, maybe I would to check this one, the second example. I would to check the size of the queue. Why it didn't work? The queue and the result. So inside the queue, I have a position of 2. So this testing case, it should be -1, but I give a 1. Normally I should not put it inside. Yeah, normally I should not put index 2 inside, because here is the length of the queue. It is equal to 1 plus the nums r plus 0. It equal to 0. Yeah, let me also print out the nums r. And so it is the queue, it is this 2, and now I have a 0. So this 1 plus 0 Yeah, 1 plus 0 is gonna be a 1, so modulo 2 is gonna be 1, but why I still get it? Yeah, this is confusing. Let me just print out this one to check what is the final value for the length of the queue plus the nums r. It is 1. Yeah, but only if it equal to 0, I want to put it inside. Yeah, even this is 1, I still put it inside. This is a string. Yeah, it is a 0, but why here it is a 1? Oh, because I put something inside the queue, it is become to 1, but it should be 0. So at this position, it is a 0, so the result would plus equal to 1. Yeah, it seems I have to check. I have to check if it goes out of the range. Definitely it is not possible. So for this example, for this 0, if it goes out of the range, definitely it is not possible. So I have to check it from some place. So even maybe let me check maybe from here. I want to check it if it goes out of the range. So currently the place is going to be r. If r plus k, yeah, if r plus, let me check from where I want to check it. Maybe I want to check it. It should be outside. It should be here. If this r is the right position, if the right position plus k more than the end position, so if it is more than n, definitely it means it is not possible. So I'm gonna return a -1 first. So this is my right pointer, but I'm gonna have a window size with k. Yeah, so even if it is a 0, but I want to check it inside. So if it is more than this number n, it means it goes out of the range. And basically the length of the nums is n, but if it is more than that, it means it goes out of the range. And definitely I'm gonna return a -1. So for example, this is a position this r equals to 2, and my window size is k equal to 2. 2 plus 2 is going to be 4. 4 more than this number n is 3. 4 more than 3. If it is more than that, definitely I'm gonna return a -1. Yeah, it should be like that. Now let me just delete the print to have a check if it works. Yeah, it seems it is just because I forget to check about the edge cases. So if this window size r plus k, it is more than the length of the range, it means I want to get some positions, but it goes out of the range. Yeah, if it is equal to n, it is still okay, but it is more than n, definitely it is not possible. I think that's for it. Yeah, thank you for watching. See you next time.